Okay, now I don't know how you felt about the gravimetric analysis problems we did, but this is often what people consider the first hard problem in AP chemistry, and that is finding the average atomic mass, like the percents, when you find them algebraically. Um, and it can be a challenge, but if we keep track of our numbers, it shouldn't be that big of an issue. So let's read through problem two and then we'll talk about it, how we approach it. So now a couple of things, when they're wanting you to solve it this way, there's only ever going to be two isotopes. They will not make you do this for a three or more isotope problem. So that's one thing that's pretty nice, is that you know you're only going to have to handle two isotopes. And the other thing is, when you think about the problem, if you have more than two isotopes, they're not wanting you to do the problem this way. And if you feel like they are, you need to go back and reassess and look and see what they're actually giving you and what they're actually wanting. The only time we have to do this distribution and find the problem is when there's two isotopes. Otherwise, we'd have to use the quadratic equation. So there are two stable isotopes of calcium. Calcium 40 has a mass of 39.96, and that's AMU. And calcium 46, 45.95 AMU. There's a big gap there. Using the average atomic mass of calcium from the periodic table, calculate the percent abundance of each isotope of calcium. So when I look up calcium on the periodic table, what I notice is that the average atomic mass is 40.078. So it's slightly more than that 39.96, but it's very close to 39.96, which indicates that we're going to have more of the calcium 40. But how much more? Now, this one, there's really no way, either you know how to do it or you don't. There's no easy way to, figure out a percentage. You just have to kind of be on the level of the problem and solve it. And so here's how we're going to solve this. So the first thing that we're going to do is arrange our problem, so no spoilers. Okay, so this is looked up from the periodic table, and that's going to be the answer. And sometimes they'll give you that, or sometimes you'll just have to look it up from the periodic table. And so here's my first isotope. There's that 39.96. And so I just assign that X, because it's going to be this. If you go back to that last problem, it's going to be this times the decimal percent plus this times another decimal percent. When you add them up, you're going to get this answer. Now, what we've got here is X, and then in a decimal percent, your two decimal percents, when there are two isotopes, have to equal out to 1, just like in percentages. If you have, two grades in the grade book, they have to add up to 100%, okay? So, like they got to count until, it's 100%. That might not be the best illustration, but if you've got two things, if you've got choice A and choice B, they're going to have to be all of it. There's not like a third isotope that we have to worry about. Okay, so it's just this one and this one. And so that's why you can do X, and then I always do my second one, 1 minus X. And a lot of times that gets me into a negative situation, which I'll show you, but it's not that big a deal. So once we've done that, our next job is going to be to show you something that you can actually see. So we're going to distribute right here. And so this times X is 39.96 times X plus, and then I distributed here, 45.95 times 1 is 45.95. and then 45.95x. And so I've distributed everything out there, and it's going to still equaling 40.078. And so I have two x terms. I have one just plain number term, and then the answer is a plain number term. And this is the part that always gives me the heebie-jeebies, just a little bit, is what you do is you can combine those terms, okay? And so take that 45.95 and minus it from the 40.078 to move it over to that side. Then take that, and this is the part that never seems like it's going to work to me, but it always does. 39.96 minus 45.95, see those are your two x terms, and you just take this minus that, and you leave that x on there, and that's where I get that 5.99x, and then this taken from this is going to be that negative 5.872. Divide by that 5.99 that you get from doing this minus this, and you get x is equaling 0.9803. So, and when you make that percentage, it's going to be 98.03. So that calcium 40 is going to be 98% of all the calcium. And when you look at the average atomic mass of calcium being so close, being 40.078, you can see that that is an answer that you should be pretty comfortable in getting. That this is, because we assigned it up here to this first isotope, so that's going to be the x, and then you take 1 minus that, and that gets you 1.77%. And, I just went ahead and made it a percentage here to solve it. If it's a decimal, that's going to be 0.0197, okay? And so the calcium 40 is the great percentage of all the calcium on the planet. The calcium 46, not a whole lot, but it is, however, enough to bump that average atomic mass up from being just 40 to 40.078.